Hello everyone, myself Sumangla Biradar. So in the previous video we discussed about Tiger hash function, and as we know that in the Tiger hash function it consists of 24 rounds. So among 24 rounds, 3 outer rounds and 8 inner rounds. In the last video we already know that how outer round works. Let's see how inner round works in this video. So Tiger inner round, each FM consists of precisely 8 inner rounds here. Okay. So now earlier you are taken as a F5, F7, F9. No. So now here I am considering only one. Assume that this is your F5 and this F5 consists of how many inner rounds? 8 inner rounds here. So each of size what it is? 512 bit input W to M here. Okay. So now you are taking the W here, and W is your input, and that input is of size what you are taking? 512 bit here. Okay, 1 bit here. W consists of what it is? W0, W1 up to W7 here. W is one of the input blocks Xi. Xi is your input block, and that input block once again you are further divided as a W0, W1 up to W7 here. And all lines are 64 bits here. So this W5, what is the line you are having now? It is of size what it is? 64 bits here. And for the input values for f of m comma I here. So that is f of I value it is starts with what it is? M is your multiplier, and I value is the, okay, first it starts with 0. Next I value is 1, next it is 2, and it is repeated up to 7 here. For I equal to 0 to 1, 0 comma 1 2 3 up to 7. Okay, so now these are the things. So now you have to take the input values. So those input values are this one: ABC, BCA, CAB, ABC, BCA, CAB, ABC, BCA. So these are the inputs you are taking for this FM functions here. Okay, Tiger inner round. So let's consider one round of the inner round here. As we know that FM, okay, each FM comma I is a function of what it contains. Each this f of m comma I may be 0, I may be 1, or it may be up to 7, any value it is. So what is the input for this FM? So for this FM inputs are what? A, B, C, okay, and W here. Okay, that WI here. W is divided as a W0 to W7, and W0, if it is f of m comma I is 0, then you have to take as a W0. If I value is 1, W is 1. If I value is 2, then W is 2 here. So now for this level, if I take as a 0 level, so then what are the inputs for this level, for this f of m function? That is A, B, C, and W0 are the inputs here. And also you are using one more thing, that is the M here. M is what here? M is the multiplier here. That is what? Input values of ABC are from previous round here. So from one round, what are the output you got now? In the last class I explained about the outer round. So in there, what are the output you'll get now for the F5? So that one you are taking as an input to the F7 here. Okay, so that is the procedure here. So for the any of this f of function, you are getting the input. That input is depends on the output of the other f of f5 or f of 7 function here. And WI is of 64 bit blocks of 512 bit. Okay, 512 bit, that is divided as a 7 blocks, or as a W1 to W0 to W7. It is of the size is 64 bit block here. 8 blocks you are divided. Each block is of size 64 bit here. And M is the multiplier. You are applying the multiplier of the logical multiplier function. And C, if you are using the C, that C once again you are subdivided as a C0, C1 up to 7 here. Let's see output of one f of mi is. So if I take as a f of m comma 0 here. So from this, after applying this function, what are the output you'll get now? How we'll get that output? Let's see, and how this function works. C is equal to C plus, okay, sorry, C XOR Wi here. So Wi is what it is? W0. If you are performing the f of m for the 0, okay, round, then it is what it is? It is W0 plus C here. After applying this XOR operation, what are the result we'll get? No, that result you are taking as a C now. Then what's the value of A? A equal to A minus S0, S1, S2, S3. So all these are what now? These are the substitution blocks here. So this is the lookup table, and with the help of the lookup table you are substituting the blocks here. So now for substituting the blocks, you are substituting the blocks of which values? C0 for S0 and C2 for S1 and C4 for S2 and C6 for S3. So all these are the inputs C6, and you are applying the S substitution for this one, and here you are taking the 8 bits, and these 8 bits you are mapped to the 64 bits here. Okay, so that is each block is of size 64 bit, and that one you are dividing as a C0 to C7, and those are you are mapped to the in substitution blocks of 8 bits to 64 bits here. So now here you are using this symbol. This symbol indicates what? XOR. So after applying this X box, what are the output you'll get? No, that output you are XOR. That XOR you are once again subtracted from this A. So whatever the result you will get to, that result you will take as A now. Then what is the value for B? B is the B plus addition. So substitution of S3 XOR with the substitution of S2, XOR with S1 and XOR with the S0. So after applying this XOR operation, what are the result we will get now? That result you are performing addition with the B, and that result you are taking as a B value here. And B once again you are modified with the multiplier. M is the multiplier. That one you are multiplied with the B, and that B you are taking as a final values. So these are the A, B, C are the inputs to the each f of m function here. As I told earlier, so what are the values of W0, W1, W2 here? So those are the values you are getting as a key value here, and that key value you are getting from Tiger hash key schedule algorithm. With the help of this key schedule algorithm, you will get the initial key values here. So now input is of X, and that X you are divided as a sub blocks as what it is, X0, X1 up to X7 here, and W is what it is. It is one of the input of the blocks Xi here. So now these are the values for the Wi by using this key scheduling algorithm. What it tells? W0 value if you want. So that value you are generating as a key by using what? W0 minus W7 XOR with the this constant hexadecimal value here. So after applying this, what are the result you will get? To that result you are subtracting with the FW0, and that result, what are the things you will get? No, that one you are taking as a W0 as a hash key value here. For the W1 you are performing what here? XOR with the W0 here. W2 it is X2, that is the block value, plus W1 here. So next here you are performing W3 in the W3, W2 XOR with the W1. Complement it is. Complement it is reverse here. If you are having the 1 in the W1, so that one you are taking as a 0 here. And those bits once again you are using the left shift operation here. How many bits you are shifting now? 19 bits you are shifting. After shifting that, what are the result you will get? No, that result you are XORed with the W2 and subtracted with the W3, then you get the result as a W3, and this W3 you are using as a key. Okay, so in the same way for this W6, Wi XOR with the complement of W4, and it is right shifted here. Okay, here right shift the how many bits? It is the 23 bits here. After shifting the 23 bits of the complement of W4, if you are perform XOR operation, that XOR operation result if you are subtract with the W6, then you will get the key as a W6 here. So these are the some of the key scheduling functions you are using to generate a key value here. So in this way, if you are get the key values no, so in that situation what happens here? Small change in X will produce a large key change in the key schedule output. So that's why, so in the hash function, for the message, if you want to generate a hash value, no, as I told earlier, if you make the simple addition of the white space in the message also, then you get the hash value is totally different due to this process here. Is it clear now? This is how Tiger hash function works here. Okay, Tiger hash function consists of what? It consists of 24 rounds. Among 24, 3 outer rounds and 8 inner rounds for the each outer rounds here. Later you are performing multiplier and also you are taking the constants and you are shuffling the input in the each function level. Then what are the output you'll get? No, that one once again you are performing the arithmetic operations, that is, or logical operations, that is XOR, addition and the subtraction. Then you'll get the final result here. And even in the each function f of m, what are the values you require? No, that one you are taking as a key, and that key is based on this tiger hash key schedule here. By using this tiger key hash key schedule, you'll get the key values, and these key values you are taking as a input for the each function, that is in or round here. Okay, is it clear now? Okay, thank you.